Improving cooling system efficiency, Part 3, mechanical chillers. Here's a mechanical chiller is used to remove heat from the building. It's the mechanical device that removes the heat and maintains the temperature and humidity within the building at a given set point. As shown in this photograph, the mechanical chiller consists of an open cooling water loop that flows through the condenser and through the cooling tower. So we see here in this illustration the condenser water section of the cooling tower. Water from the chiller water from the cooling tower enters the condenser, passes through the condenser, picks up the heat, and then is pumped back to the cooling tower where that heat is rejected to the atmosphere. There's another section of the chiller called the evaporator, which also is a heat exchanger, and that removes heat from the chilled water loop. So here's an example of one of those heat exchangers. This happens to be a two-pass shell and tube condenser section of the mechanical chiller. And water enters this at the bottom of the chiller condenser, passes through the ID of the condenser tubes, makes a bend and comes back through the condenser, and then exits where that water that has picked up the heat from the condenser is sent back to the cooling tower. And this process gets repeated over and over as the condenser water cycles back through the condenser, up to the cooling tower, back to the condenser again. Again, in doing so, it conserves water and improves overall the efficiency of water usage. So let's talk a little bit about chiller efficiency. We said along the way that chillers operate along a performance curve that measures the kilowatts of electric power consumed by the compressor motor versus the chiller load. And this concept is fairly straightforward, but very important when it comes to evaluating the overall efficiency of the chiller operation. We can estimate the chiller load based on this simple equation where we're looking at the chilled water flow rate in gallons per minute. This is the water that's flowing through the evaporator section of the chiller. So we're looking at the chilled water flow rate, gallons per minute, times the temperature differential, the return and supply temperature of the chilled water. And if we do the calculation, we arrive at the tons of load carried by that chiller based on temperature differential and flow rate of the chilled water. The 12,000 is just a conversion factor that says there are 12,000 BTUs per ton of cooling. So this tells us our chiller output. Another way we can do this is by looking at the control panel on the chiller, and most chillers display the percent of load on the chiller, and you can calculate it from that. So by looking at these values for kilowatts of power and the chiller output, we can come to an estimation of the overall efficiency. And we'll talk a little bit more about this later in another one of the segments. So for now, though, what do you need to know about mechanical chillers? First of all, that the centrifugal chillers consist of an open loop, which flows through the cooling tower, and then a closed chilled water loop that flows through the evaporator section of the chiller. And further, that the chiller compressor motor consumes power, electric power as measured in kilowatts, to remove heat from the building. So that's the big energy consumer, is the power required to drive the chiller compressor motor to accomplish this heat transfer.